Okay, 4.5, first order differential equations. This is very cookbooky and complicated, but once you do this a few times, you'll see it's actually kind of cool how we solve this. So first of all, what we have is to have a first order differential equation. Remember, you have to have only y prime. We don't have y to this double prime or triple prime. It's got to be just a first order equation. And then we have some kind of function of x times the y prime plus another function times y equals a function of x. So it's this general scheme here. And these, the a, the b, and the c are all functions of x. And yes, they can be just numbers. That's perfectly fine. They can be ones, right? So here's what we call the standard form. And in order to do the system I'm going to show you here, we need to make sure that we have everything in standard form. So it has to look like this. And then what we want to do is get the y prime by itself. So we start here in this form and divide everything, whatever we need to do to get this y prime alone. Usually that's going to create some kind of a rational expression here and a rational expression there. It's okay. It doesn't need to, but it can. And this might be ugly. Don't worry about it. Just leave it because we're going to do something to it that's going to hopefully simplify itself later on. So, but this y prime has to be by itself. And then what we're going to do is we're going to turn those complicated things into a p of x and a q of x. This is the most important part here. So we're going to use this p of x to create something called an integrating factor. The integrating factor is, we're going to use the Greek letter mu here. So this is mu of x equals e to the integral of p of x. So this is e to an integral of this thing. So once you do that, you're going to create this mu of x here. Then what we're going to do with that mu is multiply the whole entire thing, both sides, by it. What's going to happen on the left is you're going to create a product rule situation. You don't have to do anything. It just does it to itself automatically. And then we're going to identify that product rule, and I'll show you how to do that in an example. Once we do that, the left side is already integrated because the product rule is the derivative, right? So when you integrate a derivative, you get the original function. So the original function is just the product. So the left side, super simple. And then we just need to integrate the right side. And once we do that, we divide by that mu of x, and then if there's an initial condition, we go ahead and solve that. So it's very cookbooky. Let me walk you through two examples right now. First example we're going to look at is checkpoint. Actually, I think here, checkpoint 415 is just identify the p and the q of x here. So here's our original equation that they gave us in the problem. First of all, we do not want to deal with this fraction, so I'm going to multiply both sides by this whole denominator, and I get this. And from here, some friends might want to try and distribute this, but remember, the goal is to get this y prime alone, so we don't want to be making more of them by distributing this. In this case, here's my y prime. It's supposed to be on the left. X is just supposed to be on the right. Here's a y term. I got to move that over, so I'm just going to add that to both sides. So I have something y prime plus something y equals something x's, right? X's in numbers. Now I'm going to divide by this x plus 3, and now I have that standard form. So in this case, my p of x would be this. My q of x is that. So this problem just had you do the separation and identify. Pretty straightforward. Next, we're going to look at checkpoint 4.16. In this case, we're actually going to solve it. So here is our equation we're given. We don't have an initial condition, so we don't have to do that step. Step 1 is put it in standard form. So whatever's attached to this y prime, divide by that. So here we go. I did it. That lets you identify the p of x, which is right here. After it's in standard form, our next step is to find the mu of x. Mu of x is e to the integral of whatever p of x is. So this is e to the integral of dx over x minus 2. So I'm pulling that over here. What is that? Well, I'm sure you see that that's the integral of dx over x minus 2 is the ln of the absolute value of x minus 2. When I plug that in here, so I have e to the ln of x minus 2, and I think the problem, I didn't write it here, but I think it said just assume that x is bigger than 2, meaning we can get rid of the absolute value brackets. We don't need to carry them over. Remember, e to the ln, they cancel. So then my mu of x is just x minus 2. So we've identified that. Then we go back. Step 3 is then multiply everything by that mu. So I'm going to multiply everything in my equation by x minus 2. And then what happens is, in this case, notice that we had the x minus 2 on the bottom here and over here. So this actually canceled. So by multiplying by x minus 2, it actually cleaned it up a lot here. So here we are. Now, here's the most important part, step 4, and it's the trickiest one. On the left, do you see this thing right here? This is actually the product rule. So if this was my u, wouldn't my du be 1 for this u? And if this is my v, wouldn't that be my dv? So notice I literally have u dv plus v du right here. Well, what is that? Well, that's the derivative of u times v. So right here I have the derivative of u times v equals this thing. Well, when you integrate, the integral of a derivative is just removing these two signs. You're not actually changing anything here. So as we move forward with these steps, on the left side, you're just going to go, here's my u, there's my v, write them down here. You don't need to integrate them. You just copy them down because the integration cancels with that derivative here from the product rule. The only thing you need to integrate is the right side. So on the left, I have x minus 2 times y. X minus 2, oh, not my y, I'm sorry. Yes, the uv right here, I'm sorry, uv. And then we integrate this right here, put the c. Then I'm going to divide everything by whatever's attached to the y, and then here's my final answer right here. This one didn't have an initial condition, so we don't have to worry about that. On checkpoint 4.17, we do have an initial condition, so we're going to do the same thing. Here's my equation. So step 1, it's already in standard form, so that's good. Step 2, we find the mu. Well, the p is just negative 2, so e to the integral of negative 2 is e to the negative 2x. So I multiply that by both sides, e to the negative 2x times y prime, minus 2 to y, e to the negative 2x equals e to the negative 2x times this. Remember, don't bother to multiply those out. You're not going to help yourself there. Over here, this just becomes uv. So if you look at this, this is the u, and this is the v right here. If you see that. So that's that left side. On the right side, though, this is parts. E to the negative 2x times 4x minus 3. So we got to do parts. Obviously, I'm going to pick my u to be 4x plus 3, blah, 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 blah. I do all my work here, and I get all of this here. I'm not going to go over this in detail, but you can follow it. You can pause and follow along there if you want. You guys know how to do parts already. And then I get to here. Y times e to the negative 2x equals all of this when I do the integral, when I finally get everything together. Then I'm going to divide by that e to the negative 2x. And notice that cancels this, that cancels this, and then it just sits here with the c. Dividing by negative 2x is the same as multiplying by positive e to the positive 2x, so that's there. I can distribute that negative 1/2. And here we go. And I'm simplifying these inner terms here to negative 5/2. And we simply plug in. And I get that C is 1/2. And then you would plug that back into the answer. So pretty tedious. The problem is always going to be the finding that product rule component.